Hello everyone, this is Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we will discuss about the irrigation canals. Types of the canals will be already discussed in the previous lecture. In this lecture, we will discuss about the cross drainage works and design of the canals will be discussed in today's class. First of all, we have the cross drainage works. What are the cross drainage works? Cross drainage works is nothing but a number of structures which is constructed across the canals or rivers, whatever it is, will be constructed various purposes, which is classified conveyance structure. Second one is regulatory structures. What is the conveyance structure? A conveyance structure is the structure which is the source of the run. Large distances can be conveyed the water to maintain of the levels approximately. The water which enters into from the main canal, from the main canal, and ultimately, and it can be reaches the agricultural fields through the water course. Water course nothing but a small main canal to a small canal which is inserted here from the water course. So this is already detail discussed in the previous class. So in the cross drainage works can be different slopes and different levels can be constructed, just like natural bodies of the railway lines, roads, and cross drainage works are required. So why? Because these can be constructed whenever you have to cross one of these small canals. We have to be compulsory. We have to require the bridge, and also we have to road, and also as well as you can utilization the hydraulic purposes. So multi-purpose can be used for the cross drainage works. So for this one, let us see one by one what are the cross drainage works, different type of the cross drainage works. Here aqueduct. Aqueduct is one of the cross drainage works. Let us see in the diagram. It is the structure which is constructed of the canal. Canal can be flows over the drainage. And the flow of the drainage below is open channel. So it is provided when the canal bed level is higher than the high flood level of the drainage. Means here the bottom here the drainage will be forms here, and of course this is a cross section. So from this one the above there is a river which is passing above the drainage bed. Here is that one. The above drainage, above the FTL level, HFL level, we have to be constructed. Let us see, here is the HFL. In the above the HFL, it can be constructed. Some of the space can be used for the flowing of the drainage. So that is we call as the above the HF level, we will construct the aqueduct. So hope you understand. Aqueduct is a structure, hydraulic structure, which is constructed above the drainage and also the above HFL of the high flood level of the drainage. So we call it as the drainage. Here you have to see in the side can be utilized for the road passage also can be constructed. One side of the road is also there. These type of the construction we call it as cross drainage works. This is also one of the type of the cross drainage works. Let us see another one is siphon aqueduct. So what is meant by siphon aqueduct? Siphon aqueduct nothing but here also the same. The canal can be passed over the drainage, but it is constructed when the high flood level of drainage is higher than the canal bed level, higher pressure level. So here see in the previous slide, in the previous diagram, high flood level is the below level of. It means some space is there for the passing and above for the flowing of the drainage, high flood level. See in this siphon aqueduct nothing but there is no gap at all. For this one the siphon aqueduct nothing but the drainage will be flows one side here and flows on the other side. There is a high flood level will be the above the level, above the level. That's why it can be flows under the pressure. Let us see the high flood level. Up to this level it can be forced, but the water, the drainage can be comes here and can be passed in this way as under the pressure, So these type of these structures. So in the previously it is also free flow. It can drainage will flow freely, but not here. Here it can be flows under drainage under the pressure. So these type of the structure we called as the siphon aqueduct. Siphon aqueduct. So another canal bed level. So super passage. In this super passage, so in the super passage, nothing but here canal super passage structure is here the structure which is canal take it below the drainage of the flow. The canal is open channel. Canal will be the open channel flow. So here the canal will be passing here. Let us see the canal. So the drainage streams of it required the canal full supply level. Canal full supply level is the below the drainage bed level. Below the drainage bed level. See that one. This is the difference in between the below the drainage bed level. So this is called as super passage. So let us see that one. It is the structure, hydraulic structure, which is constructed here. The canal is taken below of the drainage and also flow. The canal is open for the channel flow, but it can be open for the channel flow, but it can be flows here, and also when the canal full supply level is also the drainage bed level, but it cannot be mixed these two. That is the main important for the construction of these structures. So another one is canal siphon. So canal siphon is nothing but a canal siphon is the structure which is canal is taken below the drainage and the flow in the canal in the pipe. So in the pipe can be a pipe culvert can be provided here, and from the pipe it can be flows one side to another side. So this type of the construction we call as full supply level is above the drainage bed level. We called as the siphon, canal siphon. This type of the structure is also very important in the super passage. So up to this we discussed about the four types. First one is aqueduct, second one is siphon aqueduct. So third one is super passage, and fourth one is canal siphon. These are the four type of the hydraulic structures which is constructed across cross drainage works can be used. So another one of the situation is there. For suppose there is a canal is there and the drainage will be the same. In previously what we discussed, these are the different levels. Here the one level is another level. Drainage level is above or canal bed level is above, high flood level is above. So in this situation, these are the drainage. For suppose this is drainage, this is the canal. Both will be in the same level. What we have to do? So in this type of the situation, we should have to another solution is there. The particularly the same level, drainage water is admitted into the canal and one bank of the taken out and the opposite bank can be taken out. Here also admitted here the drainage, and it can be taken and it can be removed from the another of the canal side. The opposite sides of the banks opposite also allowed. So these type of the cross level is called level crossing. Level crossing means the same level which are the drainage as well as the canal drainage level and canal level is also at the same time. This is the one of the situation for the cross drainage works. So another canal at the same level, inlet and outlet. What is meant by inlet outlet? In this cross drainage works, inlet and out. In the inlet structures is the provided when the drainage and the canal are almost the same level. As we know, the discharge of the drainage is small, almost especially a drainage will be the discharge will be the capacity is low, and that drainage water admitted into the canal and suited side for the excess water discharged out throughout the outlet. This canal from the distance downstream of the junction, which will be provided at the downstream of the junction. These can be detailed in the diagram will be discussed. Here see that one. All the regularities can be what we discussed in the previous. So let us see the cross drainage regulator here. So one admitted into here and can be closed whatever to maintain. Canal drops and also we discussed. Distributor head works and also escapes. Figure of the complete detail of the cross drainage of the works. Next, cross regulator, distributor head regulator. What is meant by distributor regulator? Let us see distributory head regulator. See, here is the distributory head regulator. So, the distributory head regulator is that head of which the distributory and the branch canal. It controls entry of the water into the off-taking canals. It can be control the off-taking of the canals. So, these type of the regulator we call it as the distributory head regulators of the channels. Next one is cross regulator. Let us see in the diagram. What is the cross regulator? This is also one of the cross regulator here. So in this cross regulator, what happens? It provided in the patent channel just the downstream of the canal. Full supply can be taken off, and even the patent channel is running full, and canal regulator is also. It can be provided. See that one in the diagram you can understand easily. It can be admitted and feed from the downstream side from this control of the cross regulators by using of the cross regulators. These type of we call as the regulatory structures. All can be comes into the same diagram. Let us see the canal falls. Here the canal falls. What is the canal falls? A canal falls is the falls which is the slope of the natural ground of these much steeper, and the slope of the canal sudden drop into the canal bed level is provided. These sudden drops is the known as the canal falls. The locations as per the geological conditions, the location has decided, justified and balanced the quantities of the excavation or the filling. So let us see in the diagram we can understand these are the canal drop falls. So let us see that one. This is the canal drop or canal falls. So from this one, it can be water admitted suddenly, it can be dropped from the top to one level to another level, and it can be flow under the control of the some gates. So these type of the geologically, how much it can be depth can be filled in the canals can be understand usually, and also the construction how it can be levels can be flow of the control of the canal drops of the falls. So these are the one of the hydraulic structures in the cross drainage. So another canal escapes. What is meant by canal escapes? These are the structures which are designed from the canal when the excess rainfall occurs and the breach and the in the canal downstream. So then these are the shortest of the safety walls can be provided, and the canals can be emergency of the repairs of the work. This is called canal escapes. Let us see in the diagram. We can understand easily canal escapes. Let us see. This is a small structure which is constructed. This is type of the structure will be constructed in the main channels. In these channels, some of the repairs or maintenance of them. These can be opened for the maintenance purposes, and also it can be closed of the whatever it uses. This is the very important structure will be constructed in the emergency situations. It can be helpful. So these type we call as the canal escapes. So escapes nothing but it can be escaped the water from that from this side. So the type of we call it as canal escapes. So next we have to go for the design of the channels. So up to this we have to discuss only the constructions. Now we have to enter into the designs of the designs of the channel. How to design, how to take the values of the will be discussed in these slides. Next one is the non-alluvial channels. These are the excavated non-alluvial and alluvial also there. So these are the excavated in the non-alluvial of the loam, clay, moram, boulder, except these are the silt problem of the channel. They are relatively stable. So these type we call it as non-alluvial channels. Second one is the rigid boundary channels. So rigid boundary channels is nothing but rigid boundary channels surface of the channel is lined, and such channels are relatively high velocity and can be permitted, does not allow to get the deposited, hence the problem of silt is not exit. Next, alluvial channel. So in previously non-alluvial. Alluvial channel nothing but these are the soils with the such as salt, such as silt in the such channels. The quantity of the silt may vary the section to section, and its silt content may be increased due to the scoring of the bed of the sides. The channel maybe decreases the silting of the sections. The velocity of this one scoring occurs as the velocity of the low. In this silting of the maybe occur, such channels should be designed for the non-scoring of the non-silting of the velocity. We call it as critical velocity. This type of called as critical velocity. They are the alluvial channels. So up to this we discussed alluvial channels and non-alluvial channels. Okay, let us see the rigid boundary channels. Okay. Next, non-alluvial channels. Let us in deep we have to be design of the non-alluvial channels. Non-alluvial channels are constructed stable as it is silt problem. Such channels, these are the channels are usually in the design based of the maximum permissible velocity can be boundary safety resist. Here the side slopes of channel can be taken as generally 1:1, and the cutting in cutting is equal 1.5:1, and filling and also filling the channels is grit and rock of the safe side, and the excavated channel is generally kept is a 1:1. Here is 1:1 escape channel, and also 1.5:1 was the 1.5:1 another side. So these type we call as the alluvial channel. So this can be design proceedings as take it as slopes will be 0.5:1 and 0.25:1 also, and 0.25:1 respectively. These are the some of the designs considerations can be taken in the sloping respectively. In a hard rocks area, the sides can be taken as vertical. The design of non-alluvial and non-alluvial channels are the Chegis equation is and Manning's equation. These are two type of the Chegis and the Manning's can be taken as to solve this and design for the channels. So let us see then the Kennedy's theory. In the Kennedy's theory is designed for unlined canals. Unlined canals. In the Kennedy selected number of channels in the upper buried region, but does not require silt clearance of the more than 35 years of the supported for flowing of the non-silting, non-scoring of the velocity. Kennedy's theory fact is let us see the bed of the channel of the resistance of the flow and critical eddies, and these eddies can be eddies nothing but a small type of the walls of the black can be deposited in the channels. So these are the deposited in the bottom. Eddies can be for it can be reduce the velocity and the flow and obstruction will be forms, and the capacity of the bed width will be the channels also be reduced for this type of the channels. That is one critical velocity. There is a formula. The critical velocity to find out non-scoring velocity function. A velocity is equal to d is equal to depth is equal to d, and it is given by relationship between the scoring velocity and the function of the depth will be taken as v naught is equal to cm all to the power of d to the power of 0.6. We will take it as value. Next, where C and N are the coefficient of the suggested by the Kennedys for channels of the vary down region. So, under such situations, we have to take the value. The values of C will be the different. For light sand soils, we will take it as 0.53, and light sand silt we have to take it as 0.59, and sandy loam we have to 0.65, and coarse silt is equal to C is equal to 0.70. The values of the C and N can be taken as C is equal to 0.55 and N is equal to 0.65. So these are, and another, thus the equation for the critical velocity becomes V naught is equal to 0.55 and D is equal to 0.64, where we represent mean velocity of the flow 0.64. So the mean velocity have to take the values of the C, the values of the M will be taken as the consideration of the design of the different conditions of the channel of the flow. So where it can be V is equal to mean velocity of the flow will be calculated by using the formula. Next, unless otherwise, if M is equal to not M is equal to 1, Kennedy's theory, the mean velocity is equal to given by V is equal to under root Rs. So where C represents Cheggy's constant, and Cheggy's constant is equal to 23 plus 1 plus N 0.015 plus S by 1 plus 23 plus 0.0015 divided by S into N divided by under root R. By using this formula, C represents Cheggy's constant will be calculated. When N represents the Cotter's rugosity coefficient, and S represents the bed slope. S is equal to bed slope. R represents hydraulic mean radius, and R is equal to A by P. Area by A is cross section, and the P is the weighted perimeter. So this is the briefly about the Kennedy's formula to find out. There's two conditions here we discussed about in this slide is very important. What we discussed here, the M value is equal to 1 is given, how to solve this problem. So M is equal to C. By applying this formula, we have to be find out the how the calculation of the C value. So this is the Kennedy's theory. Q discharge calculation. The side slopes is equal to 1:k. The cross line A is equal to BD plus KD whole square, and weighted perimeter P is equal to B plus 2D under root 1 plus K square. The kinetic procedure of the designing unlined canals. The Q is equal to A into V naught, and V naught is equal to 0.55 M into D to the power of 0.64. So V is equal to, by calculation of the velocity, V is equal to under C into under root RS. Where the C value, as we know very well, previously discussed, 23.2 plus 1 plus N whole to the power of etc. As we discussed in the previous one, 23 plus 1 plus N plus and bracket begin 0.0015 divided by S, and 1 plus 23 plus 0.015 divided by S into N divided by R under root 2 value. This is the value which we have to be considered. In this one condition for the design, very important in the Kennedy's theory is given. If when the bed slope is given, how can we calculate it? If bed slope is given, assume that the trial velocity depth is equal to D, and calculating the velocity V using the V is equal to 0.55 M, D to the power of 0.64, and determine the cross section A is equal to QA. As we know that Q is equal to AB. By applying this formula, A is equal to Q by V. So that's why it can be converted like that. So next, it can be taken as, assume the side slopes is equal to 0.521, and compute the values of A is equal to BD plus 0.5 into d square, or b is equal to 0, a minus 0.5 d square by b. Of course, this can be changes as per the given the data. We can have to be changes of the values of the formula like that. Next, compute the weighted perimeter and assumption of the data, and computed width is equal to p is equal to b plus under root d to the power of under root 5. So next, compare the hydraulic radius. How to calculate the hydraulic? R is equal to, we know very well the formula, R is equal to A by P. So A is equal to BD plus 0.5. By applying the formula here, BD plus 0.5 D square divided by B plus D under root 5. So calculating the actual mean velocity V and Cooter's equation is very important equation. V is equal to 1 by n plus 23 plus 0.00155 s divided by 1 plus 23 plus 0.00155 by s n by under root r under root r into s. The velocity is computed, and now it is found the Kennedy's method, design depth corrections, and also otherwise the repeat the steps will be assumed different depth will be taken as and the Kennedy's theory equation can be applied by Cooter's formula, where d is assumed to be the next of the trial and error of the vice versa. So based on this formula, you have to find out the based on the given data, what is the QM, discharge, mean depth, and N and S are given, side slopes are given. So if it is given, we have to use this formula to find out. Next, Lacey's theory. Lacey's theory is nothing but, so Lacey's theory is also one of the carried out study designing the suitable channels of the alluvial soil. This is developed regime theory. Regime theory is formulated number of expressions based on the observations. The salient features of Lacey's following, what are they? They are the soil can carry the certain discharge, and the bottom width of the bed of the slope channel undergo modifications by silting and scoring. The channel is now said to be the regime channel. The regime channel is defined as the stable channel which the bed width and the side slopes have undergone modification by silting and scoring are so adjusted as the equilibrium attained. So these we call as the regime channel. So I hope you understand. Regime channel is the channel. It is defined is the stable channel which bed width and the depth and the side slopes having the undergoes modifications and silting and scoring and adjusted to the equilibrium attained. So these type we call as the regime channel. So the channel can be regime. The following conditions can be satisfied. What are the conditions? Let us see the condition. The channel is flowing unlimited, inherent of the alluvium of the same characteristic of the transported sedimentation. Inhoration, the soil computed, loose granular materials also can be scored and developed with the same years. So silt grade is the silt which is already given the same throughout the channel. So that's type of the called a channel can resume following the conditions will be satisfied. Discharge of the channel is constant. The discharge of the channel is constant. The silt carrying the following is channel is kept sponsored, and vertical eddies can be bed of the slopes can be channel. The sides grades of the play important role in this channel. The silt factor can be F is equal to 1.76 under root D, where D represents dia of the silt particle in mm. This is the regarding the channels, and today we will discuss about the cross drainage works and regime channel, and also the Chedis Kennedy's theory, how to calculate the given different conditions. Remaining will be discussed in the next class. So thank you. Thanks so much.
Like, share and subscribe. Hit the bell icon for more updates.